Hello, it's Dr. Harris back with another video from the second slideshow in our Tidy Data chapter 5 of our data computing course. And just want to look through another example, give you an idea of a case where what we're looking to try to do may have some impact on whether we want to pivot narrow, pivot longer, pivot wider. And so a common situation in statistical studies is what's called a repeated measure study, where you take repeated observations from the same individuals. We saw a repeated measure study earlier in our fasting table, where we took two measurements, a before weight and an after weight, for each of three individuals when they went on a lengthy fast. And so we're going to see if we want to generate graphics out of a repeated measure study, putting it in a narrow format, that is, to pivot longer, is going to often be a useful thing. So let's look at an example. You may want to stop the video here and go and access and learn about the labels experiment, but I'll briefly recap it right now. Individuals were given a taste out of two different types of peanut butter, or what they thought were two different types of peanut butter. They were peanut butter from two different jars. One was given a brand name label Jif. The other one was given a generic label, Great Value. And they were asked to rate the taste of the peanut butter when they could see which jar the peanut butter was coming from for them. What happened in actuality was that both jars contained Great Value peanut butter. And so we're basically doing a psychological study where if people are more likely to rate the more expensive name brand of peanut butter higher than what they consider to be a generic brand. And we can also explore whether or not men or women reacted differently to this. And so, again, I invite you to look at the data set for labels and to read the help file for it. And here's what the data set looks like, at least the first 6 entries. We've got the Jif rating. I do realize that the Jif is spelled with only one F. This is a data set that Dr. White created, and I just have not elected to go in and change this. So we're going to see Jif with 2 Fs instead of 1. So we've got Jif rating, Great Value rating, and we've got the sex of the respondent. And this is the graphic that we want to generate, where looks like we're faceting on sex, and we're doing measurements, or we're just looking at the ratings of the Great Value and Jif for each individual, and then we've connected a line for the two measurements for the same individual. And so what we see looking at the graphic is that by and large, looks like all but one of the women rated Jif higher than they rated Great Value, or the peanut butter that came out of the Jif jar higher than that came out of the Great Value jar. Whereas a little bit more mixed for the men. Looks like a couple of men rated the peanut butter out of the Jif jar lower, but many of them, or a few of them, rated them the same as well. So we do see some differences there. We'd like to figure out how we can generate this graphic. And so we've commented already that generating graphics is better probably with after doing a pivot longer. And so we'll do that here. We want to put the Jif rating and the Great Value rating labels in a single column called which, and we're going to move the values to a column called rating. And then rather than deal with the lengthy names Jif rating and Great Value rating, we're going to shorten those by mutating, coming up with a variable called better. And better here does not mean which peanut butter jar, which jar they thought the better peanut butter came out of. It's just a better name for our labels. And so we use the command recode, and we're going to look at the variables out of the column which. That's where the which comes from. And we're going to rename Jif rating simply as Jif and Great Value rating as Great Value. And so if we do this, pivot longer, we're going to get something that looks like this, where we've got the sex column and the which column. So now we've got Jif rating and great value rating side by side in there, the ratings for the peanut butters. And then better is just, again, renaming the values that are in the which column. But there is an issue here. We have failed to keep track of which numbers go with which individual. We have a suspicion that they're ordered, but we don't have an easy way to tell, to tell the computer which ones go together. And so rather than try to get in some heavy duty coding on that, what we can do is we can actually just add an ID label to each row in our initial data set. And so we're going to call labels narrow. We're going to mutate labels. We're going to add an ID column before we do the pivot. So we're going to add a column called ID, and n row just counts the number of rows. And so I'm going from 1 to the number of rows in labels. And then after I've added that ID label, I can pivot. And again, I'm only affecting the Jif rating and great value rating columns. And then I'm going to sort on ID. And if I run this, I'm going to get a table that starts off looking like this. And so now we've got the sex, the ID, and then we've got the shorter label along with the rating for each individual. And at this point, we can actually figure out what our command is, our ggplot command is, that's going to generate the graphic. But I'm going to leave it up to you to play around and figure out what needs to go in var1, var2, var3, and var4 to generate the graphic. So we want to ggplot, we set an aesthetic. We are going to want a group, and then we add we use geom point and geom line. We want to connect, and then we're going to facet on some other variable, and we can add a label on the x-axis. So it's an exercise for you to fill in the correct variables and to see that you do get the graphic that we targeted a few slides back. And then finally, we've got one more problem for you to practice on. I'd like you to look at the chick weight data set, and we want to ask which diet is going to produce the most growth for chicks over time. So read up on chick weight. You can go to the help file and take a look there too. Here's the graphic that we want to generate. Mean weights of each diet group over time. And so we see that all the weights of chicks are trending upward as the days pass, but some feeds seem to generate higher growth in the chickens. And so on the last slide, we've got the general command that we want to use to generate this graphic, but I'm asking you again to fill out all the variable names. And so why don't you play around with this and see what you can do with it.